Now that we have a general understanding of the ways in which ethical issues are typically rationalized inside the scientific community, today in Part 9, we will hear more about the effects of morals and ethics on the delivery of science and math to young learners.
Not all galaxies are spiral galaxies.
Right.
So you mentioned something about that critical speed at which things are forming. And so that has some bearing on the development of spiral galaxies, right? Because if stars were exploding too often and too fast, we wouldn't get some of the phenomenon that we have now.
Yeah, and interestingly enough, that's been a question for a long time. An astronomer, Fred Zwicky, way back in the 40s, pointed out that galaxies are rotating far too fast to be held together by the gravity of the stars they see it. And that's where dark matter came into being, because most of our universe is stuff we cannot see. I suppose you could say this, an artist starts a painting and he splotches paint up there and slowly but surely the details get more and more correct until he's got a finished product. Science does the same thing. A lot of theory, leads observations, and a lot of observations lead theory because they go hand in hand.
So then experimentation has to come in there at some point.
That's right, and that's the point. That it's one hand washes the other. Without data, the theorist goes nowhere.
Right.
Without the theory, experimentalists don't know where to look for.
Yeah.
So these two branches of physics, of science, go hand in hand.
So could you say then that the theoretical part is more based on intuition than it is necessarily on known fact?
The great leaps in thinking have been made not from the theory and the observation, but from the philosophical.
What comes first, the technology or the breakthrough? All the technology is right here at the end. Existence, and you just make a timeline.
Yep.
All the technology is right here at the end.
Yep.
So as our technology continues to improve and become refined, then we would expect, I assume, that our knowledge level will also
Goes right up.
go right on up, right?
Absolutely straight up.
Sometimes one thing will come before the other, but there's also in science a lot of accidents.
Oh yeah.
A lot of
serendipity.
Yes, serendipity. Mistakes that lead you down the road towards discovery.
Right.
So not everything is logically based.
And that's why we have all the religious myths, because every human being asks the same question once you get big enough to ask the question is, why am I here? Where am I going? Where did this all come from? Philosophy answers those questions in the religious sense, which is, this is the way it is because I said it. Science says, I'm going to figure out what's really going on and have proof for these things. Knowing what is really going on in the universe, and by that I mean everything, our behavior patterns, everything else, is the way you avoid disasters.
There's a person named Steve Fuller. I don't know if you've heard of him or not. He's an epistemologist, and he says that science has got us into this situation, the global warming, and now science is saying, well, we got global warming, let's fix it. If you have science on one side that have a philosophical difference with scientists on this side, what do they do to the data to make their story work?
Cheat.
One has to be wrong, right?
But science did not get us into this situation. Man in his decision making got us into this situation.
Science enabled those things.
Well, but science is knowledge, and knowledge can always be perverted. I'd say that scientists are like all people. There's some of us who are corrupted, and if you pay us enough money, we will give you the answer you want. And then there are some of us who won't do that, and then, believe it or not, you can get a lot of trouble when you won't play the game.
So what's a layman to do? What is a person who is weak in math and weak in logic skills, and they want everybody to come up with their answers for them? What are they to do?
It comes down to our politicians. And our politicians are more, in my opinion, interested in preserving their careers and their philosophy than they are for the general good. Unfortunately, my experience is a lot of people want to believe what they want to believe.
In other words, they want your opinion, but only if it agrees
Yeah,
with theirs.
Scientists are like anybody else. There's a spectrum of people in there who, depending on maybe your belief system. I mean, I know a scientist who's extremely religious, and he believes that you have to do science in a certain way. Then you've got the other guys who will just cheat and fudge their data because they want the
funding.
They want the funding, they want the fame, they want whatever it is. They're just, scientists are not monks. We are normal people with normal desires, and there's a spectrum of us. And who are you to believe?
Well, the ethical issues have to be resolved. So where do scientists fall on the spectrum of ethics? I mean, are there ethical rules that guide science?
Because as I say, we're all humans. You have your personal code of ethics.
Okay.
And if my code says, boy, I can cheat to get an advantage,
Right.
I'll do it.
Right.
And if you have my own personal view, I'm going to do what I think is right. Science is not A, B, C, D, E. Oh, there's the answer. Because there are many missteps in there. And you can
process.
believe in your concept so strongly that even if you're the most ethical scientist in the world, you can still be, down the wrong path. The data doesn't come up and say, here's the answer. You have to interpret it. And we are all subject to bias.
Then would you say that your worldview could have a bearing on your scientific work?
Sure, absolutely.
It's a bias.
Absolutely, it's a bias.
Worldview is a bias. Right?
Yeah. So you constantly have to be aware of that. Even as a journalist or as a news reporter or as a politician, your bias is going to be a part of who you are.
That's right.
And you're in a constant battle to keep that to a minimum, right?
Yep.
Especially if you're in scientific fact-finding work.
Yep.
Gerald Joyce, he's doing RNA world research. He's clearly committed to a kind of a Darwinian, an evolutionary paradigm in his thinking, and I think that it has infected his research. But at the same time, his worldview has infected his research. My worldview, as a theist, has infected everything I do. But I'm compelled by that worldview to be morally responsible in my skepticism. And I don't think there's anything about an evolutionary worldview that requires that. Surely some are responsible in their skepticism. Nobody has a corner on the market of goodness in that regard. But for instance, in an essay he wrote, the whole habitable zone idea has come down to, if you have water, you're going to have life, which is probably generally true. But it's not like you can just add water and get to life. You have to be able to sustain water. You have to have the right amount of water. And people don't realize, while we see a lot of water on planet Earth, by mass, the total water store of Earth is 0.0203%. You need to be water poor, not water rich, to sustain carbon-based life, which is the only game in this universe. And so he cites that as, look, we'll find life out there if all we find is a place where water could be. And I think that's fantasy.
So was that an example of being morally irresponsible in your skepticism?
I think so. Dallas Willard is the guy to credit for that. He takes it to everybody. He says, whether you're theist, atheist, you need to be morally responsible in your skepticism, which means you have an opposing view. You need to study it thoughtfully, honestly, and actually understand it. And when you come to that spot, now you're authorized, so to speak, morally to criticize it. You got to realize, in that lab, I think it's the Scripps lab, there's an enormous amount of intelligent design going into the fabrication of these synthetic life forms. Like we were saying, people need to realize you have a commitment, whether you admit it or not, whether you know it or not, you've got a bias. And please don't pretend that you're completely objective. Stop it. Nobody's completely objective. But you can be responsible with your bias and your skepticism.
Most scientists are willing to back off because they know we don't know all the answers. I mean, the best scientists, of course, are a little humble about the things we don't know as well as the things we do know.
Right. To have a position as a scientist, I believe you would have to somehow put aside most of your personal ideas about other things when you're doing science. Mm-hmm. Would that be a fair statement? I mean,
yeah, right. You have to approach it that way. And, the biggest challenge to that, I don't think comes from faith or religious belief. I think it actually comes from the fact that science, the modern professional science world, is extremely competitive and difficult. And so
the funding and everything else.
So people are fighting over proposals, money, their livelihoods, ability to hire students, pay their salaries. And, that gets a little personal. So
and ethical issues start to arise then. And,
so conflict of interest is a big one. And, scientists are continually faced with little subtle decisions about conflict of interest where, one decision could benefit them slightly and one might not, and then what do they do?
Sure.
So I think the scientists' hardest decisions these days are not in their actual work. They're trained well and they know how to take data. They're not going to make up data or fudge the data. It happens pretty rarely. I mean, obviously it does occasionally happen, but it's when you're in a extremely competitive situation and you can oversell your ideas or even sort of distort the landscape of ideas for your own benefit.
Yes.
And it's a fairly subtle thing, but it is clearly distorting the purity of what would be a true scientific approach.
Right. Could they clone humans, or could they do something to DNA that would really cause some sort of a Pandora's box without any safeguards?
I really think scientists and philosophers really need to work together on this. One of the branches of philosophy is ethics, this inquiry into how things ought to be, the difference between right and wrong action. However, it's difficult to do ethics without actually thinking hard about the science. The science can tell us what are some of the implications of cloning, for example. Can we do it safely? What does it mean to clone? Do the people who are cloned, do they have rights, right, in the same way? And so I think the philosophers and the scientists can work together on these questions, I think, in a helpful way. Yeah.
Do you think it will ever come to that? Will we ever try to clone humans, or has it been done and we just don't know it?
I suspect that our technology will increase, and I'm not sure really what will stop the sort of human imagination from attempting these things, either legally or illegally.
Alvin Plantinga says, well, quantum mechanics can't really coexist with Newton's laws. Well, how do you classify quantum mechanics? I mean, is it real science? What are we to believe when they say something can come from nothing based on quantum mechanics?
How credible is quantum mechanics? It's a inquiry that is relatively recent in the human inquiries. It's an inquiry into the smallest things, the particles, and so because it's relatively recent, I think it's also quite speculative in some of its theories, and I think we're making progress in understanding the nature of these small particles. But I think, like with any theory in science, one has to be careful. Oftentimes the theory is presented with more confidence than what the scientists who are actually doing the research would think that it is. And I know this just from investigating the primary literature, and I would encourage that for people. They read a news article, says something can come from nothing, right? Or we created life in the lab, or the universe came into being from nothing and science proves this, right? Find the footnote in that article, and find that primary source, and even if it's very technical and maybe not, you can't understand all the vocabulary, I really encourage people to do this, whether or not they have the educational background or not. Just read that original article and you will see, even without understanding the vocabulary, that there are nuances and complexities and assumptions built in that the scientists themselves recognize, but that the sort of popular press is leaving to the side because they're trying to popularize the science, because this is how they get the funding, etc. And so I think it's important to be intellectually humble.
Yes.
I think that's one of the virtues that drives science, is this intellectual humility, this curiosity, and a willingness to test everything,
Yes.
even the experts.
Yeah, right.
Yeah.
Right.
Over 1/3 of our scholars strongly resist philosophical or religious explanations for morality. Typically, their ethical beliefs are relativistic. In other words, their moral decisions vary from person to person and situation to situation. Unfortunately, relativistic beliefs based on postmodernism must violate the law of non-contradiction. Realistically speaking, beliefs in objective morality usually belong to people who believe in a moral lawgiver, the one who exists outside of creation. Research for our documentary was strongly driven by the profound question, how do you know what you claim to know? Now that we know our scholars better, it should be interesting to find out what areas of knowledge matter most to each of them.
I think everybody should be able to understand probabilities and chance. It's really important for people to understand, to change their mind about understanding their own lives and the lives around us. I think that the concept of randomness and how many random events can look like something that is purposeful and organized and not random, this is a really important concept. I also think people should be able to know something about scale. Microscopic scale and macroscopic scale. I think it gives you the right perspective of where you are. I think the idea that we're so focused on our human life and the scale of things that are available to us to see, smell, touch, I think you should get some kind of a scientific education that gives you the perspective of scale. Personally think it would be really good if everybody knew evolution and understood it. You understand your place and your imperfection and the randomness that contributed to us becoming who we became. I also think it's important to understand evolution, to kind of put an end to this science versus religion debate. We didn't just argue not a better kind of chimp. This is not what Darwin said. Evolution is not finished, and we are not the last thing to evolve and this is it. Everything is evolving. We are evolving. It's sad that we have to discuss this, but I have one thing that it is something that I would like to pass on.
Okay.
The Dalai Lama came to the neuroscience meeting, the annual meeting of the Society for Neuroscience a couple of years ago. He said something that goes like this: if science discovers something that is in conflict with the books, the ancient books of Buddhism, the books have to be rewritten. He didn't say that science abolishes religion. He said the books have to be rewritten. There are people who believe that there are truths, multiple truths. We shouldn't pitch books that have been written thousands of years ago by people who lived in a particular society against experimental science going on in the laboratories. The books have to be rewritten. Knowledge has grown. We cannot stop knowledge from growing and understanding of the world around and creating knowledge by ideologies and by sort of threats to certain truths that are held by certain people. So I think if people understood science and understood where knowledge comes from, we would be a better society. Who we are is what we do with what we know. Yeah. What we know is determining of possibilities of what to do. And then from that possibilities you choose. And that choice of what you do based on what you know is who you are.
Well, I think every human being on planet Earth needs to have some scientific knowledge and understanding of the origin of the universe, the origin of the first life, and the origin of humanity, the three big origins questions. Now, I come to that conclusion just based on my public speaking. Those are the three questions about science I get more frequently than any other. Mm-hmm. And to really have a good grasp of how all the scientific disciplines fit together, having a good understanding of those three concepts, I think really helps you pull together. Otherwise, you're just an expert in one discipline.
Yeah.
Well, I always go back to, rather than the facts, it's the method that I think is important. Mm-hmm. For example, if someone tells you green tea, is healthy for you, first off, do your own research. If a doctor tells you that you need to lose 20 pounds, go on the internet and find out, what's the average weight of someone my height and, my age. And sure enough, you're actually 50 pounds. No, I don't know. But, do your own research. That's number one. Okay. And then, do the statistics. That's number two. And then number three is, ask for the control data.
Oh, yeah, the
I
original
really
research,
think that's very important. When they said that green tea was healthy, what did they compare that to? Vitamin water, brown tea, and did they see actual statistical effects?
Significance, yeah.
Yeah, statistical significance.
They need to know some about science because it's understanding the world. They should be being educated. Like they need to know about language and about art and about music. They should know something about all of that, about geography, about history,
right.
And the same about science, the physics, chemistry, biology. They should know something about it. This process of being educated, maturing intellectually, and therefore having a better view of the world, and therefore being able to do better work, contribute better to the world.
Improves their quality of life.
For them and for others. Here's what there's the two sides of the coin.
Right.
Yeah, I think young people should be encouraged to follow scientific interests because they're so incredibly rewarding. There's nothing else like it. Yeah. Nothing like the sense of discovery. Nothing like the sense of satisfaction, and nothing like the way that you could pass that on to your children or your students or other younger people. But I wish we would get a little bit more serious about removing the roadblocks to that.
Okay, how so? Yeah. What kind of roadblocks?
I haven't ever been a K through 12 teacher, so I can't speak with immediate knowledge about those environments. But it seems like science and math are diminished because of other interests.
Oh.
Yeah. So there's nothing wrong with athletics. But if the main reason to hire a teacher is because that person also can be a coach, then you're not hiring the best scientist you can hire. You're doing a project of convenience where science class is sort of the byproduct.
Yeah.
But in California, you can't hire a coach in a high school, so you hire teachers who can coach, and you do the same with all the other extracurricular activities. So unfortunately, I'm afraid that's led to a situation where athletics are driving the people who actually appear in a math or science classroom, because in the process of becoming a qualified person in exercise science, or what we used to call physical education, you get enough math and science to receive that credential.
Yeah.
And I think we need to be a whole lot more flexible about how we treat teenagers and math.
Yeah.
Because math is so fundamental to the sciences, and we have this weird system where if you got off track once when you were 13, tough. You're never going to be a scientist because you're not staying in that math progression. That's really what we're throwing away so much human potential when we do that.
You're right.
Yeah. You can't necessarily reset your options.
Yeah.
And I think that's just kind of tragic.
Yeah.
I hope that gets better.
Yeah.
Maybe it will.
Yeah, hopefully.
Actually, I think it's more important that people know what science really is So this definition of what science is as just a description, I think that's one very important piece of information, because a lot of people seem to have a misunderstanding about that. They think science is threatening their beliefs, but it's really not. It's only a description. What's threatening their beliefs are maybe other people interpreting scientific results in a certain way that threatens them. But if you separate science out to what it fundamentally is, a description, then it's really not threatening. Another thing is to know that there's a lot of science out there. There's a lot of things about nature to learn still. And I would say I'd like everybody to know that, because not many people do. Even I was talking with my wife, and I illustrated maybe if the entire realm of human knowledge is this table, then we know a very, very small circle on this side of the table. That's how little we know. I wish everybody would know that, because I think they would be more motivated to learn about science. Like, oh, there's more to learn. There's more interesting things to do. I can be involved in it. One thing I often hear about maybe pursuing a PhD in science is that it would be so difficult to find something new. Like we know everything would be so difficult. But it's quite the opposite. There are so many topics that you can study. The number of topics is huge. What's difficult is the perseverance to stick it out. Keep doing that research, stick with it, try and prove your hypothesis, or keep up with your method. Make sure you have results that are reliable and conclusive. And I would say that's the more difficult part of doing science.
Yeah.
I would say curiosity is paramount to scientists, wanting to know how things work and how things relate to one another, and what it is that we can do with that knowledge, how we can apply the things that we discover to help us care for creation and care for one another, and to mitigate human suffering. So I think curiosity is key. Man, the quest for truth is definitely one of my central core pursuits. I'm pretty passionate about that, and I have a couple of siblings, and my mother's still alive, and they say, yeah, it was pretty evident from a very early age when I would ask questions pretty much nonstop. Even after most kids had been worn out, I'd still be asking questions. But I think it's a very rewarding pursuit, and I think that Scripture tells us that it's a rewarding pursuit. I think Scripture encourages us to seek for what's true.
This we know. Science textbooks, politicians, and the media have equivocated the term evolution. Therefore, Darwinism is now taught as fact. Elimination of philosophy from the domain of knowledge has resulted in voters who lack critical thinking skills. By embracing relativism, moral and ethical standards are vanishing. Daily, we are witnessing the surrender to anarchy. What can we do to resist this decay? Be sure to catch our final episode. I'm John Jones.
To request your study guide, email us at thoughtmonopoly@gmail.com.